So today we'll be looking at how we can reduce unwanted energy transfers through a couple of different methods. So this could be how we can reduce unwanted energy transfers from like for keeping the home warm and many situations like that. So first of all, we have thermal insulation, and second of all, another way is through lubrication. So these are both for very different things. Lubrication is like when you apply an oil or grease to an engine to minimize the friction of it and to allow for smoother movement. So first of all, if we look at this home image here, what we can see is we want to keep the house warm, let's say, and it's freezing cold outside. So how do we keep the house warm when it is very, very cold outside? That's what we're going to be looking at today. We want to basically reduce energy transfer to the outside of the home to just keep it warm. So energy is being transferred or it's leaving the house, and we want to contain that heat energy inside the house. Okay? So then let's have a look at different ways in which we can do that. Now, first of all, we need to remember that we want the house to be sealed or closed so that air is not able to pass out. Windows should be closed, the door should be closed. Overall, it should be like a sealed container. There's also so we also need to know what convection is. So convection is the heat transferred through liquids and gases, and because of convection currents, which are through fluids, energy can be transferred. So for example, little things like including curtains are a great way of stopping energy being transferred. So, simple ways to reduce energy transfers are through fitting in curtains, fitting in carpets, draught excluders, and so on. Now let's look at conduction. So when conduction is heat loss through a solid. So convection is through a fluid, so liquids and gases. Conduction is through solids. So that's when heat is lost directly through a solid. And this can be through the walls, through the windows, and so on. So first of all, through the walls, how can energy be reduced using through the thick wall? So one of the ways is through cavity wall insulation. So this is when you blow an insulating material into the gap between the brick and the inside wall, which reduces the loss by air circulating inside the cavity, and it reduces loss by convection through the cavity as well. Overall, the heat loss that is conducting through the bricks and the cavity is reduced, and we call that thermal conductivity as well. So that's the air gap between. So that, yeah, that's kind of a few pointers on what I just spoke about. Secondly, through the windows, we can add something called double glazing. So single glazing is just one sheet of glass, whereas double glazing is two layers of glass with an air gap in between. These kind of windows have air or vacuum between the two plane, and because air is a poor conductor, this keeps the house warm because it reduces heat loss through conduction. So these are a couple of things that you could be asked and you should be able to speak about as well. So the last thing we're going to look at is how to reduce friction when an object, so reducing friction, resistance an object encounters when it's moving over a solid or through a fluid. Okay. So the problem with friction is that it reduces the efficiency of the energy transfer and it can cause objects to heat up. So if you have friction between the cogs and the chain of a bicycle, it makes it much harder to pedal. But if you add oil, this is a type of lubricant, we can reduce that friction and so cycling can become a lot easier. If you make planes and cars more streamlined, this also reduces the friction, so less fuel is used to make them more efficient. So this is how reducing friction can also speed up the process, the speed up the car. So making things more streamlined or adding a lubricating oil and the like. Now, what I'd like you guys to do is pause the video and see if you guys can have a go at this sixth marker, which is on describe how walls of a building affect its rate of cooling and explain ways to reduce the energy transfer. Okay, so this is just to do with how the walls can affect it, but it's for 6 marks. So you need to plan out all the key points that you're going to include. So what are the features of a wall? Use like the thickness, the thermal conductivity, how they link to energy transfer, and so on. Okay, so have a go at that. And here is a answer. So a thicker wall, it will mean the building will cool more slowly. A lower thermal conductivity of the material the wall is built from will mean that the building will cool more slowly. For example, brick has a lower thermal conductivity than metal, so it's better to build walls out of brick than metal. And then the second thing is obviously cavity walls, okay, because cavity walls are to do with walls. Energy transfer can also be reduced by using thermal insulation, a material with low thermal conductivity. Cavity walls, with two walls with a gap between them, will reduce energy transfer as the cavity will contain an insulator. Another thing I would add to this is because it contains an insulator, energy will be the insulator, for example, air, it will energy is transferred as conduction, so it will sorry, convection, so it will slow down as well. Okay, so I hope you found that lesson useful. You do let me know about what in the comments. So do let me know any new things that you've learned or any questions you have.